Okay, a very good day to anyone who's watching this video. I'm Lim, and with my teammate Lim Yong Zhe, we are going to present AACS2034 Fundamentals of Computer Networks. So, oops. Okay. So these are the table of contents. We have introduction, network topology, addressing table, addressing design, and digital resources used. So for the introduction, we are actually recently hired by MediaWave Broadcaster as their network engineer to design their network with a topology with a location with an administration at level 2, newsroom at level 1, production at level 0, location B at marketing level 2, human resource level 1, engineering level 0, and location C with 2 international news departments. Location B is 500 meters away from location A, and location C is 200 meters away from location A. So we come up with this network topology. So we can see that there are 3 locations, each with their respective switches and routers, each with interconnected with cables. Okay, so let's see the switches and routers we use. So for the switch, we use the 296024TT model of the switch. We use this switch because he has 24 fast Ethernet ports that we could minimize the number of switches needed for works because there's a lot of ports, so therefore reducing the cost. And we have 2 GB Ethernet ports which are high speed, which can provide high speed connection between the switch and router, so it's better. So for the router, we're using the router PT, so we installed a PT router NM1CGE in the routers to satisfy the requirement of the gigabit internet ports for the switch to router. So next, we use 2 types of cable. For the cables we use to connect end devices, different end devices, we use the straight through copper cable to connect them because they are more common, cheaper, and easier to install. Also, they also work well in short distance connections. So let's say in a department, so we can use the copper cable to connect between departments, and the fiber optic cable for the devices, for the same end devices like routers to routers. Okay, so with a fiber optic cable, one of the advantages is that it can connect long distance connections, so like between locations. So we can use fiber optic cable, although it's expensive, but no choice. Okay, so next for the host number calculation. Well, this is a lot, so I'm just gonna talk about the 2. So I picked location A, administration department, because it's the largest number of hosts. So we can see that after a 65% growth, we times 165%, we get a number 829.95. We round up to the next whole number, and we got the final host as 830. So the next example is a router to router. We have 2 initial hosts, but we don't need the additional 65% growth, but we need the addition of subnet and broadcast address, which we plus 2. So the final host number is 4. This applies to all the routers. Okay. So next, for the prefix calculation. So for the prefix, we chose the number of host address in the largest subnet group, which is the previously discussed administration department. And after calculation, we need to calculate the minimum number of bits needed for the host address, which is 2 to the power of 10. This is 1024, which is larger than 830, which is 10 bits. So the prefix just grab 32 minus 10, we get 22 prefix, because this is a fixed length host subnetting. So we use prefix 22 for all the hosts, all the department. So next, for the subnet range calculation. Well, this is because we use the IP address 10.0.0.0. The IP address class is class A because it falls in the class A range. The default subnet is 255.0.9.0. The custom subnet mask after calculation is 255.255.252.0. So these are some general calculations like total number of subnets, host address, number of user address, and number of bits borrows. So for the subnet range, after calculating, we get that the total number of host address is 1024. So for every subnet range, we have 1024 host addresses with -2 minus the subnet, the network address and the broadcast address, we gain 1022 usable addresses. We apply it in the range, so we get these results. So let's example for the calculation, the switch calculation. So we just use the administration department as an example. So for the for the first switch users, for the first switch, we have 2 reserve ports, one for the router and one for the switch next to it. So because we use the switch with 24 ports, so we -2 because those 2 are reserved, so we get 22, and the ports needed for deduction after the first switch is our 820 minus 22 is 798. So the second to the 37 switch. So by calculation, the reserve port is also 2, but the 2 is the previous switch port and the next switch port. So we also grab 24 minus 2 for 22 for each switch port left available, and we times that for 36 because we have 36 switches in between the range. So we get 792, and lastly minus 798 with 752, we get 6. Okay, for the last switch, the 38 switch, you have one reserve port, which is the previous switch from the previous switch, which is minus 24 minus 1 is 23, and the number of ports after the subtraction is 23 minus 6 equals 17. So we have 17 empty ports. So in conclusion, we have 820 hosts in the admin department. We used 38 switches, and we have 17 empty ports left. Yeah. So next, I'm gonna give it to my teammate Lim Yong Zhe.
Okay, so my name is Lim Yong Zhe, and today I will present for the addressing tables and the network configuration for the routers, the switches, and the end devices, IP configuration as well. So for now, I will explain for the addressing tables. This part is for the routers, and so basically, we set for the each location have one router, and for the routers there will be like gigabit ports and then the fast Ethernet ports that will connect to the end devices and to the switches. So these are the listed IP addresses and the subnet masks for the routers. Next, this is the addressing table for the switches, which have the following IP addresses with the same subnet mask. And the interface is VLAN 1, which is the default interface for every switch. And this is the default gateway is the same as a router A, which will following with the corresponding location, and the default gateway is with its same IP address with the switch for the default gateway. For the next one, these are the end devices addressing table, which will also connect to the default gateway, which is also the same for the IP address of routers for each location. Okay, wait. So now I will switch to the packet tracer. So first of all, I will show the network configuration for routers. So this is the router A, and I set a password for the routers and switches, which is CL caps A33. And once you enter the password correctly, you need to enable it, which will enable you to enter your password again, which is CLA33. But then we also set a secret for the routers and switches, which is AACS2034. Now you are in the router. Now we need to configure the terminal. Well, I already said it, so actually, let me exit real quick. I will show run for the router A, and these are the IP addresses set for the fast Ethernet and gigabit Ethernet, which will connect to the switches and the route and the end devices. These are also proof that I set for the VTY lines and the line console 0 for the password. and also a banner for message of the day, which it will prompt when you enter the router, just like this. Okay. So for the next one, this is the switch. I'm taking an admin switch as an example, and it's almost the same. The same password, same secret. So I'm going to show run. So basically, this is the interface is VLAN 1, which is where I set the IP address for is 10.0.0.2 with the subnet mask 10, which is shown here. And the default gateway is from router A, which is the same for the IP address of the router. And I also set the same settings. So for now, I will try to test the ping connectivity from admin PC. So first of all, I'm going to ping hold on a second. I'm going to ping the admin laptop, which is ping 10.0.0.4, and it will give me a reply. And so that's proof that it will ping and then connect to the end devices on the same department. Now I will now ping for the router, which is 10.0.0.1. Which is connected. The next one, let's try to connect to the location B. Let's try for the marketing PC. So let me ping the marketing PC, which is 10.0.12.0. That's the IP address of the marketing PC. So first, so now this is actually proof that it actually pings. Let me redo that again. And they're all connected. Because the first one, there's a request timeout, but it's okay. And let's try to ping for location C. Let's try to ping for the end device of International News PCA. As you can see, it's trying to connect for the first time, but eventually it will still connect. So let me do that again. Then there you go. So that's proof that the ping connectivity is stable for the network topology. And also, we also have a static routing protocol for our routers, so they can connect to the end devices of each location. These are the static routing protocols that are set for the network addresses for each router, which here this is for router A. This is for router B. And this is for router C, which will connect to all the end devices for various locations. So now the ping connectivity, that's the ping connectivity for now. And let's go back to the PowerPoint. So these are our digital resources used for our assignment, and then it includes the GitHub, Google, Discord, Facebook, YouTube, and of course the Cisco Packet Tracer, WhatsApp, and the Google Docs, of course. So that's the end for our presentation. And thank you.